So now remember that the purpose of doing the ecosystems unit is for this goal 1. The learner will conduct an investigation to build an understanding of the interdependence of plants and animals. So why we're doing this is to complete competency goal number 1. And remember, way back at the beginning of the unit, we said that goal 1.01 was describe and compare 7 common ecosystems, communities of organisms, and their interaction with the environment. Now, we broke that down into a definition of what ecosystem actually was, and we defined communities of organisms as those living creatures, those living organisms, animals, and plants, and then interactions with the environment and how they interdepend on each other. They need each other. So, I also want to draw your attention to when we did this page here, and this looks like a big gobbledy mess. However, you understand what this means, how we have living and non-living parts of our ecosystems, and when one part of our ecosystem goes bad, that really affects the rest of our ecosystem as well. Something else is going to follow to go bad. So keep this in mind as we move into our next section, which happens to be pollution. We're going to scroll down to our pollution slides, and they are right here. So we've got our pollution. The definition technically of pollution is something that harms an environment. However, we do use pollution in good ways. We use it for a reason. Not all pollution, but the ones we're going to talk about. There's a reason for using the things that pollute our environment. One happens to be the fact that it comes from humans, and the other one, the other fact that I want you to remember is it's usually to do good. Of course, that's not the case if we throw papers down onto the ground, but that's not what we're going to be dealing with here in our ecosystems. So we are going to understand that we're talking about pollution which comes from humans and that it usually does good. Okay? Next slide here. There are 3 kinds of pollution that we're going to talk about in this part of the ecosystems. The first one is acid rain. The reason why acid rain happens is because of things that humans do. We need to drive our cars, we need to heat our homes, and we need to have factories to make the things that we need. So this is why this is what we need to do. This is what humans do that's good. I don't think that you want to give up any of these things. However, it could create a problem. Okay? Down here, scroll up a little bit, shows our second pollution that we're going to talk about, and that is salt. We salt the roads in the wintertime, usually when it's slippery. It's used so that we don't slip and fall on ice, and it's so our cars don't slide off the road. It keeps us safe. Of course, we don't want to be unsafe. We're not likely to stop using salt. However, it does cause some damage to the environment. Our ecosystems will be affected. And now there's a third pollutant that we're going to talk about during our study here, and that happens to be fertilizer. Fertilizer can be a really good thing. It is for crops and gardens to grow better. We put it on our fields so that we have the food, the vegetables, the grain, the fruits that we need. They're really big, they're really sweet. When you go to the grocery store, usually you pick the foods in the produce section that look the biggest and the prettiest, and fertilizers are going to help that. So I don't think we want to stop using fertilizers. However, there is an adverse or a negative effect to the environment. Okay, our next slide is going to go into a little bit more detail with acid rain. We did have a lesson already on acid, and we talked about the pH scale. The pH scale is used usually on a scale of 1 to 14. Our scale, however, did not use a scale of 14. It was more like this one here. It was in the 3 range, and it went up to the 5 range. When we put our paper down onto the soil and got the paper wet, we compared it to the colors here, and most of your, actually all of your soils were up here in the higher numbers. A higher number is good, it gets a thumbs up, and a lower number is bad. We don't want it to be a low number. That means it's very acidic. It can burn our crops. So, acid rain. Things that are acidic are lemon juice as well as vinegar. We're going to be using the vinegar here in our experiments here, so we'll circle the vinegar. Again, lemon is very acidic as well. If it's basic, that's exactly the opposite end. 7 is neutral in the beginning, or right in the middle. That would be our water. Okay? The way that we get acid rain, let me scroll down so you can see a little better. The way we get acid rain is by burning fossil fuels. Probably a new term to you. So fossil fuels are really old things buried deep in the earth from fossils that when burned provide energy for us. Think about dinosaur bones. A lot of people, when you say fossils, they think of dinosaurs. So These are things that used to live a very long time ago. Erosion has moved soil over. We have glaciers come over the top of these things, and they get buried, and they stay there for a very, very, very long time, and that heat and pressure causes them to fossilize. No air can get to them. They become very hard. Well, some things like coal, for example, is way deep down in the earth. It is a fossil fuel. We can't get any more of it because it's from billions of years ago, and we burn it, and it gives us energy. The way that this pollutes the air is that smoke from car pipes, chimneys, and factory smokestacks put chemicals up into the air. So here's some pictures here. You've got the car exhaust when you're driving your car. That smoke that comes out of that tailpipe is what's going to help, not help, but is going to aid in putting chemicals up into the air. These are your chimney smokestacks here, and these are factory smokestacks as well. Okay. So as we're driving our cars, as our factories are working, and as we're heating our homes, we have these chemicals that go up into the air, and now this goes back to our weather unit. You have clouds up here, and they are gases, so we can't see them, we can't smell them, but they do rise, and they combine with the oxygen in the air. Well, when we get condensation to happen, and that gas starts to turn into a liquid, those gases are still stuck in the liquid, and they end up falling with our precipitation: rain, hail, sleet, snow. There are all ways that acid rain gets down to the ground. So this is the process. We put it in the air through the things that we do that we don't want to give up, the things that help us live comfortably. Floats around in the air, gets caught within that oxygen, turns into more chemicals that are very acidic, and those rain down into the ground. They get down onto our land, and they get down into our water systems as well. Now, you can't see acid rain because the acid part is just a gas. Again, we can't see it, we can't smell it. However, this is a model that I found. I thought it showed it really well. It is a pollutant. It's not good. It's not clean. And so this is, again, a model. We're using models in class. Our ecosystems are not the real thing. They are man-made. They're a model. We can manipulate them. But this would be a showing of kind of a dirty cloud and then some dirty raindrops. So this would be a way that you could visualize acid rain. But remember, you can't really see it. When it's raining, you don't know if it's clean rain or dirty rain because you can't see and smell the gas. Okay? A little bit more on this. These are just some pictures of the effects of acid rain. Hopefully you can see these okay. This would be, a mountainous area, lots of forest area, and then you have these brown spots in here. And these brown spots are what is, would be evidence of the acid rain effect. It hurts the plants, it gets down into the roots, it burns the roots, it kills the leaves on top once it gets into our water systems and when it rains down. This is a water ecosystem right here. This is an aquatic ecosystem, slow-moving, probably a pond, and there are a lot of dead trees, dead vegetation in the front, just a lot of sticks, but not in the back. It's still pretty green back there, so it hasn't been affected so much behind. And then we have, I don't want to move that, I want to scroll this way. Buildings can be affected by acid rain as well. Notice the discoloring here. Some of the colors are bleeding off. A lot of buildings will wear away. The stone will actually start to get holes in it. That's an effect of acid rain. And then fish kills. Fish can't live in pH that is very acidic if the number is very low when we test it. Their body systems can't handle it, so a lot of times that will cause them to die. So that's our summary for acid rain. Next, the second one is road salt. The reason why we have road salt is because it lowers the freezing point. Water will freeze and snow will freeze at 32 degrees Fahrenheit. If we put salt on the road, the temperature can get as low as 23 degrees before it's going to actually freeze. So we're not going to slip on the ice until it gets much colder. So we put the ice on the roads to protect us from sliding off. This is what it looks like when it's being put down. When you're in an area where there's a lot of snow, oftentimes you'll have a snow plow and the truck will come and it will be dumping the road salt onto the ground while it's driving. And then I have another picture right here. This is what it might look like on a road. This is the road salt left behind. This is where it becomes a problem. No problem while it's on the road. In fact, we're safe. It will melt the ice that's already there and prevent it from freezing if it's a little bit warmer, or until it's a little bit colder, but it can burn the plants. When it rains and that salt washes away down into the soils and our roadsides and gets into our creeks, it can wreak havoc. It can cause problems. And so this is a picture of a roadside kind of vegetation here, a landscaping, and all of this vegetation here is burned off. It is brown. This picture here also shows what happens when it gets into our water systems. It will kill eggs. Just like the fish with the acid rain, if the pH is off, the fish can't survive. Salt is also something that hurts the body systems of our animals. And so when you have eggs, the fish lay their eggs, and the snails lay their eggs, and the frogs lay their eggs, a lot of times they will die, they won't hatch, and then we will not have a population of animals that we need to sustain the equilibrium or that interdependence in our ecosystem. So when they die, other things are going to follow, just like that slide earlier. I've got one more slide to show us our last pollutant that we're going to talk about, and that's fertilizer. So fertilizer is used in the farming or the agriculture industry. This would be just an example of a field of grains, fruits, and vegetables. We grow these things, we eat these things, we need food to live. So it's a good thing. The fertilizer helps these things grow big, really juicy, puts them in really good condition so we can put them on our shelves in our store and we'll want to buy them. They'll taste really good too. So if we use fertilizer, we have some good effects. So remember, everything that we use that is causing a pollution is used for good reason. Humans need them, and they do good for us. However, there's usually a consequence to that. Here, when we're fertilizing our fields and we're growing really good crops, when it rains down, that fertilizer from the fields are going to get into our water systems right here. That might be the underground water, or it might be rivers and streams, ponds and lakes, and then it's going to ride down and have bad effects for the aquatic organisms that live in the water ecosystems. So I've got some pictures here to show some effects of that. Here, again, hopefully with the glare here you can see well enough, this would be much algae growing in this water here. If the fertilizer helps plants, well, algae happens to be a plant, and it's going to grow very well because it's going to be well fertilized. That's what we want to happen for our crops that we eat. Not really so good here because it's going to block out the sunlight from getting to the organisms underneath. Remember, sun is that energy source. Sun is going to create food for other plants, and if those plants down below can't get the sun, they're not going to get the food they need, therefore they're going to die. Well, what eats those plants? Well, for one, duck. Remember the duckweed that we studied. This duck, look at what it has to swim in here. It's not going to do very well in this kind of environment here. The ecosystem has had a massive explosion of the plants on the surface of the water because of the fertilizer that rained down into the water, or into the waterways, and we've had an overgrowth of duckweed in this one right here. A little further down, a little kind of web here. Plants use up nutrients in the water. So when you have a situation like this, not here, I'm scrolling the wrong thing here, where you've got way too much going on here, way too much growing here, then it's using up that nutrient in the water that other organisms need to live. It's robbing everything else of what it needs, and so the plants will die. Plants in the water, just like on land, need nutrients in the soil. That's why humus has really good nutrients. We compost. It gives the soil what it needs to produce really good plants. So then the plants die if all of the nutrients are used up, and the result of that is that the aquatic organisms have nothing to eat, and in addition to that, the aquatic organisms have no oxygen to breathe. So they're going to die as well. Just like the interdependence showed on that screen much earlier. And I'll show that to you one more time. It's not that real pretty screen. But this one right here, when you lose one thing, you usually use more because of that interdependence. So this is a brief summary of the pollutants. Hopefully you understand what they are now, why we use them, and the problems that they can cause. And for the rest of our unit, we're going to be studying the effects of the pollutants because we're going to put them into our ecosystems and see what happens from there.